Hello, I'm Nick Howard and I'm a partner at Empire Engineering. Welcome to Flipchart Friday. Today I'm talking about pretensioning of bolts in offshore wind turbines. Now, why do we do it? So, bolts are pretensions to reduce the amplitude of stress variations within the bolt when subject to variable loading, thus reducing the susceptibility to fatigue failure. Right, well, whilst that's fairly short and concise, it's not particularly instructive. So hopefully in the next minute or so, I can teach you how and why pretension is applied. So in this first example, we have a case with no pretension, and we've got two blocks of metal fastened together by a bolt. And in this instance, the nut of the bolt has been done just so it's snug. Everything's in contact, but there's no compression or tension in the system. Now, if an external load is applied, say we lift this top block up and we keep the bottom one fixed in place, all that external load has to resolve via the bolt. So the bolt goes into tension and it takes the same force as is being applied to the top block. And the important bit here is that a small gap will open up. Now the size of this gap will depend on the material properties and the dimensions, etc. But a small gap will open up nonetheless. And there's a relationship between kind of the force that the bolt feels, the stress that it's induced, the strain, and this gapping, this delta X. Now the kind of key message here is that the stress the bolt feels is proportional to this gapping, to this delta X. So, in the case where we do have pretension, the situation is a little bit more complicated. And to induce pretension into the system, we tighten up this nut. So we've got our big spanner, tighten the whole system up, and we've put compression into these two flanges. So they're pressing together really tightly. You know, if your fingers were in there, you'd really know about it. And the way this system behaves under an external load is a little bit different to how it was in the no pretension example. So I'll firstly explain it by way of analogy. So if you can imagine you have a very heavy suitcase and you're going on holiday and you've put it down on your bathroom scales to check its weight. When you come to lift it away, you'll notice that as you kind of start lifting up, the arrow on the scales goes down. So when you're at, say, 50% the weight of the suitcase, the arrow's gone down to 50% its value, but the suitcase itself hasn't lifted off the scales. And you can go all the way up to, say, 99.9% the weight of that suitcase, and the arrow on the scales will go down to nearly zero, but the suitcase has stayed in contact with those scales. Now, it's only once you kind of exceed the weight of that suitcase do you actually lift it off the scales. And it's exactly the same case with our bolted connection. So you can cycle a load or increase a load from, say, 0 to 99.9%, that pretension value, and all you'll do is change the compression that's felt between those two blocks. So at a very low external load, those two blocks are pressing together really hard, and at 99.9% the pretension, they've almost gone to zero. You know, if your fingers were there, the pressure's been relieved, but everything's still in contact, and that's really important. It's only in the case where that external load then exceeds the pretension value do we start to see a gapping occur. So we get this delta X as before occurring, and it's only at that point, because we're stretching the bolt, does the bolt feel any variation in its stress. So to explain this graphically, you can see in the top case here, where we have the unpretensioned case, you can see that the bolt force exactly follows the externally applied force, and we have this really big stress cycle or force cycle as shown here. In the case with the pretension, you can see we have an initial force, and that's the pretension force, but it's only when the external force kind of exceeds the pretension does that bolt force start tracking with the external force. So in the unpretension case, big cycle; in the pretension case, small cycle. And as anyone who's done a fatigue calculation knows, it's the aim of the game to get these cycles as small as possible. So that's why we apply pretension in offshore wind bolts. Thank you for watching. Until next time.